Okay, so we found that the particle in the finite well obeys the following equations. So we have tangent of KL over 2 equals alpha over K, and the cotangent of KL over 2 equals minus alpha over K. And so we want to plot these functions. So let's first think of alpha over K. Alpha over K is just, so alpha over K is V naught minus the energy over the energy square root. And so if we think of this as a function of energy, right, so we have some value of V naught, and we subtract the energy is increasing. This gets smaller, but let's think about what this is for small values V. So as E goes to 0, we're dividing by 0, this goes to infinity. Right, so as E goes to 0 here, this goes to V naught, then we get V naught over infinity, so the curve is starting up here somewhere, regardless of the value of V naught, and it comes down, and at some value of E, when E is equal to V naught, this goes to 0. So at some value of V, this function goes to 0, and it's going to look something like that. But the greater V naught is, the further along the x-axis we'll get to 0. So we'll say V naught small V naught I don't know, intermediate, and for large values of V naught, and V naught large. So the curves look something like that. And if we want minus alpha over K, then when E goes to 0, we're doing not positive infinity, but negative infinity. So it's just a mirror image of this. So how does that work? I have to come down like this and go like that. So I'm going to do that, do like that, and this then looks like that, and this something like that. Okay, so that's alpha over K. And when these two curves are equal to these others, then we have that the equations are valid, and they imply values of the energy. So let's think of plotting the tangent. Well, let's think of tangent of theta is really KL over 2. So we could have KL over 2. Here's theta. Right, the tangent is just a sine over the cosine. So this goes at 0. We just have 0, and then it goes to infinity, right, at the value pi over 2. And then when we cross pi over 2, we get negative. So we go to negative infinity, and we come back around to here, and then we go up to infinity over here, and we are at, so here we are at pi, and here we are 3/2 pi. All right, go back to infinity at 3/2 pi, and then we come down to minus infinity, and so on. So 2 pi, go like that. And the cotangent of theta is just the inverse of this. So we are starting at infinity. We come down here at pi over 2, and then we come down to negative infinity. Not the best drawing there. Here this is pi, and then we come back up to positive infinity, and we asymptote down like that. So we are at 3 pi over 2. Sorry, this is 3 pi over 2 here. So 3 pi over 2. And 2 pi here. I got that right. And then we have another, we come back up to infinity, we come down again. So it's where these, right, where this curve, so we can sort of think of this as having something to do with the energy, because it's really KL over 2, and the energy, when the energy increases, KL over 2 increases. So we put them on the same plot. Qualitatively, we'll get the same thing, which is that these curves will intersect these curves, and that's where we have an implied value of the energy. So notice that the greater we make V naught, the more places we have for intersection, the more bound states we have. The lower V naught is, the fewer intersections we have. So if we take this curve and we bring it onto this one, if we lower V naught enough, we only have one point of intersection, something like that. The greater V naught is, the more intersection points we'll have.